Okay, it's recording. Great. So good morning, everyone. Okay, let's wait for the people who just came in to be seated. And let us continue with implicit differentiation. This is the topic we have seen yesterday. Okay, let us remind ourselves on how to differentiate functions of a variable. So before we begin, because I've seen some confusion last time, so suppose u and v are functions of x, and let the prime denote the derivative, denote the derivative with respect to x. What is uv prime? What is that? U and v are functions of x. Prime denotes the derivative with respect to x. What is uv prime? Derivative of uv, what is that? Everybody, what is that? U prime v plus v prime u, right? U prime v plus u prime v plus u v prime or plus v prime u, right? We see that? Right? This is the, what rule is it called? The product rule. Or I can say d by dx of uv, it's d by dx u, right? du by dx times v plus u dv by dx. We agree or not? Okay. Now suppose y is a function of x. What is xy prime? Who wants to help? It should be very easy, it should be very straightforward. If you find it very easy, that's totally normal. Who wants to help? xy prime. Y is a function of x. Prime denotes the derivative with respect to x. Who wants to help? Yes?
Would be y plus xy prime.
Exactly. So derivative of x, which is 1, times y, plus x times y prime. We see that or not? Yeah? That's easy, no? It's y plus x dy by dx. So far so good. If it's easy, then that's very good. Okay? That's a good sign. Great. Now, what's the derivative of e to the y? Okay, let me write it this way. What is e to the y prime? Yeah? E to the y times y prime. We see that or not? Yeah? So write it this way, d dx, right? It's dy dx, right? Times the y. We agree or not? Everybody, do we see this? Questions? No? No questions? Okay. Great. Great. Let's do one harder one. D by dx of sine x squared plus y squared. Again, y is a function of x here. How do we differentiate this thing? How to differentiate this thing? Yeah? The chain rule, very good. So, yeah? Very good. So the derivative of the inside, what's the derivative of the inside? It's 2x plus the derivative of y squared. What's the derivative of y squared with respect to x? It's 2y prime. Are we all good here or not? This side, are we all good? Yeah? Is that fine? Yeah? On the right hand, my right hand side, is that good? So, maybe a bit unclear. So I want to differentiate by the chain rule. I want to differentiate the inside times the derivative of cos. What's the derivative of cos? What's the derivative of sine, sorry? It's cos x squared plus y squared. Is this part good? Great. So I have to differentiate this part with respect to x. What's the derivative of x squared with respect to x? 2x. Now, I need to differentiate y squared with respect to x, keeping in mind that y is a function of x. Okay? If y is a function of x, what's the derivative of y squared? Is the chain rule, right? It's 2y times the derivative of y, which is 2y y prime. Are we good here? Everybody on the right? Am I right? Is that fine? Yeah? Is that good? In the back, is that okay? Yeah? In the middle? Yes? Are we? Is that good? Really? Okay, great. Yes, sir. Yeah, sure. So, I have to differentiate this thing here, right? I need the derivative of this part with respect to x times cosine of x squared plus y squared. That part is fine, right? How do you differentiate this thing with respect to x? What's the derivative of x squared with respect to x? 2x, that's easy. Now, what's the derivative of y squared with respect to x? So y is a function of x. You agree? If y is a function of x, how do you differentiate f of x squared? The chain rule, right? So this is 2 f of x times f prime of x. Right? Y is a function of x, so it's 2y prime. Okay, are we all good here? Is that clear or not? Yeah? Okay, so maybe we can put it in terms of dy by dx. Okay, so really this is how hard it will get. Things like that, it's how hard it will get. Okay, enough spoken, let's do examples. I'll do examples from the book. Find dy by dx, x squared minus 4x x squared minus 4x. Find one minus 4 plus 1 is equal to 2. Okay, everybody. So when I say find dy by dx if this, then I'm assuming that y is a function of x. Great. How do I differentiate this? I have to differentiate both sides with respect to x, right? So let's apply d by dx on both sides. Great. Now, what's the derivative of the right-hand side of 2? What's the derivative of 2 with respect to x? 0. That's easy, right? So let me write here 0. Great. The derivative of x squared with respect to x, what is that equal to? 2x. The derivative of xy with respect to x, what is that? So y is a function of x. xy is also a function of x. What rule should I be using here? Product rule. So, how to do this? So, minus 4. Derivative of x is 1, right? Times y, plus x, y prime. We good so far? Everybody we good? Yeah? Are we good or not? What's derivative of y squared with respect to x? 2y, y prime. Are we good or not? Yeah, very good. Is equal to 0. Really, what do I have to solve for now? Y prime. Let's see, what can I do? So it's 2x minus 4y minus 4xy prime plus 2y y prime is equal to 0. So it's 2x minus 4y. Really, it becomes just an algebra question, right? Minus or plus, well, whatever, minus plus y prime minus 4x plus 2y is equal to 0. What is y prime in that case? So you just have to solve for it, right? Y prime, just solve, bring this to the other side, so it's 4y minus 2x over 2y minus 4x. You can simplify it too, so it's 2y minus x over y minus 2x. And this is dy by dx. Are we good? Are we good? It's just an algebra. 4y minus 2x, unless I messed it up somewhere. I don't think so. Is there any mistake? I think it's good. Yeah? Are we good here? Yeah? Okay, great. So, let us continue. Doing more and more examples. Still the same question. Find dy by dx. X e to the y is equal to x minus y. These are examples from the book. Great. How do we proceed here? Find dy by dx. Also find dy by dx. How do we proceed here? I have two equations. What do? I differentiate both. I have two sides of the equation that are equal. I differentiate both with respect to x, right? So let me differentiate both with respect to x. Who wants to volunteer for the first one? Any volunteer for the first equation? For the first part? For the first derivative? Yeah. Yeah? At the beginning, sure. E to the y. Now let us keep in mind that y is a function of x. So the derivative of x is 1, e to the y, plus, very good, plus x, awesome. You have to differentiate e to the y with respect, keeping in mind that y is a function of x. How do we do that? It's the, everybody, it's the chain rule, right? Yeah, is that good? So e to the y, what's the derivative of e to the y with respect to x? It's just y prime e to the y, right? Are we all good here? X minus y, what's the derivative of x minus y with respect to x? 1 minus y prime. So far so good? Everybody, are we good? Are we fine with this or not? Yeah? Please raise your hand if there's something that is not good. Yes? Yeah, I can tell you find dx by dy, right? But in general, it's y with respect to x. Okay? Yeah. Everybody, please. Are we good or not? Any questions? Last call. Any questions? Please do not hesitate to ask if you have any questions. Great, awesome. So what do I have to solve for now? I have to solve for everybody. I have to solve for y prime. So what do I get done here? Or what do I have to get? What do I have to do here? So it's I put the well, it's e to the y minus 1 is equal to well, let me do it on the other way. That's fine. Doesn't matter really, but let's see. It's 1 minus e to the y. Bring it the other side. Y prime x e to the y plus 1. So y prime is 1 minus e to the y, and then x e to the y plus 1. Okay? Everybody, are we good here? Yeah? Any questions so far? Let's do one more. Or what? Let's see. Suppose that let's see. Let me double check. Okay. Fine. Do you guys know increasing and decreasing functions? Have you seen this before? That's fine. Okay, then I'll fine. Y prime at the point where x is equal to 0, x is equal to 1, x is equal to 1, and y is equal to 2. Okay, so I have a curve. This is a curve. Y plus x squared y cubed is equal to 10. And I'm just asking you to find y prime at the point where x is equal to 1 and y is equal to 2. Okay, notice if you plug in x equal 1 and y is equal to 2, what do you get? You get 10. Right? You agree? Plug in x equal to 1, plug in y is equal to 2. What do you get? 2 plus 1 times 8, plus 1 times 8. What do you get? 10. So the point 1, 2 does indeed belong to this curve. I mean, let me make 1. Okay. Find y prime at the point where x is equal to 1 and y is equal to 2. What step should we be taking here? We should differentiate with respect to x. Yes, sir?
Isn't it 9?
Isn't it 9? So let's see. 2 plus 1, y is 2, right? So you have 2 plus 1.
Sorry.
Yeah. Okay, great. Now, I differentiate with respect to x. Derivative of y with respect to x, what is that equal to? Y prime. X squared y cubed with respect to x. How do I differentiate that with respect to x? It's a product, right? So it's 2x times y cubed plus x squared. What's the derivative of y cubed with respect to x, given that y is a function of x? X3, y squared, y prime. Very good. Is equal to, what's the derivative of 10? 0. Great. Now I can solve for y prime. What is y prime? Y prime is what? Oh, okay, that's not that actually. No, wait. Is there any mistake? No, that's fine. That's fine. No, I think that's good, but just let's double check. Did I make any mistake? No, that's fine, yeah, that's fine. So if x is equal to what you can do here is you can solve for y prime, right? You want to solve for y prime or just plug in? Just plug in. So if x is equal to 1 and y is equal to 2, what do you get? You get y prime plus 2x times y cubed, so it's 2 times 8, right? Plus 16, plus x is 1, y is 2, so 3 times 4, 12, plus 12 y prime is equal to 0. So 13y prime is equal to minus 16. So y prime at the point where x is equal to 0, y is what am I saying? X is equal to 1 and y is equal to 2 is equal to minus 16 over 13. Is that good? So 3 times 4, 12. 12 plus 12y, yeah. Does that look good to you? Yeah? Does that look good? Did we get this? Yeah? Pardon me? General, yeah. I mean, yeah. These are nice questions. We'll do a bit more. Something like double derivative now, second order derivative. But I think for that, we can ask you for the tangent line, for example. And then that's it. Yeah. This is not supposed to be very hard, I think. Great. Find the tangent line. To the curve. Defined by defined by at the point where x is equal to 0. Now, if I have x is equal to 0, what do I have to find? This gives me an equation, right? This is an equation. If I have x is equal to 0, what do I have to find? Y, right? Is there a unique value of y in this case? So if x is equal to 0, what is the value of y? Yeah, sure, yeah. I mess it up. So if x is equal to 0, if x is equal to 0, what is y equal to then? 3 e to the y, or let's write this way. 3 0 e to the y plus y e to the 0 is equal to 4. So this implies that this is 0, so this implies that y is equal to 4. So if x is equal to 0, this implies that y is equal to 4. Great. Now for the tangent line, what do I need to find? I need everybody, what do I need? The derivative. So I have to differentiate this with respect to x, right? And obtain the derivative at the point where x is equal to 0 and y is equal to 4, right? Let's do this. Let's take d by dx on both sides. D by dx, 3x e to the y plus y e to the x is equal to d dx of 4. Great. Who wants to help me differentiate the first term? Any volunteer? Any volunteer? Please raise your hands. One by one. No. Someone else. Someone? Yes? Yeah? No? Yeah, just in front of you. You can do the second part. Yes?
3 e to the y.
3, yeah, very good. 3 to the y plus?
3x e to the y times y prime.
Very good. Plus 3x e to the y prime. Very good. Yeah, you want the second one?
Y prime e to the x.
Yeah.
Y e to the x.
Plus y e to the x. Oh, what's the volunteer for the right hand side? 0. Yeah. Are we good here? Did you all get this? We all got this, folks? Is it clear? Any questions on this? Any questions on how we got here? Please raise your hands like it's please, if you have any questions, ask it. So 3 e to the y plus 3x e to the y prime plus y prime e to the x plus y to the x. Any questions? I see some confused faces, so please raise your hand if you have any questions on this. Are we all good here? Are we all good? In the middle, we're all good? Yeah? Good? Great. Now, I have to find y prime when x is equal to 0. And y is equal to 4. What is y prime? So it's, oh man, that's a very bad. So 3 to the 4. Oh no, that's very nice. 3 to the 4, this is 0, plus y prime plus y is equal to 0. So, y prime at x equals to 0 and y is equal to 4, what is that equal to? This is just minus 3 to the 4 minus 4. Also, we can write this as y prime of 0, right? Y prime of 0. Great. So what's the equation of the tangent line? Tangent line. This is y. The slope is minus 3 e to the 4 minus 4 times x minus 0, which is x, plus 4. Right? It's the derivative times x minus a plus f of a. Are we good here? I don't know, like, some of you look confused, some of you look very comfortable. Now, if you have any questions, please raise your hand. It's not, it's better to ask now Then to be confused later on. Yes?
I would just like to recheck that we can use the other formula for the slope. It's like y minus 4 is equal to
Sure, yeah, y minus 4 divided by x minus 0 is equal to, that's the same thing, right? Let's do one last one, and then move on. Or let's do two more, and then move on. Fine. Y double prime if x cubed minus y cubed is equal to 7. Great. Awesome. Let's try to find y double prime if x cubed minus y cubed is equal to 7. At the beginning, how do I proceed? What should I be doing here? I should differentiate with respect to x. How do I do that? And then differentiate again, right? Also, I don't know if you have seen the notation, but y double prime is also denoted by d squared y by dx squared. Did you see this notation? I don't know if I put, did I put this notation? No, I did not do it. So this is also d squared y by dx squared. Now the nth derivative of y is denoted by dny dx. Okay? This is the nth derivative. I think we saw this, right? Yeah. Great. I have to differentiate y double prime. So in general, if you have a function of x, how do you find the second derivative? You find the first derivative, and then you differentiate the first derivative. Are we all good? Great. Now, how do I do this here? I have to differentiate with respect to x both sides of the equation is equal to 7. Let me do this. So how do I differentiate x cubed with respect to x? 3x squared. How do I differentiate y cubed with respect to x, everybody? It's 3y squared y prime. Very good. Minus 3y squared y prime is equal to 7. Is equal to, I have a d by dx here, I forgot. Is equal to 0. Great. So what do you get? You get y prime. Oops, I shouldn't have erased that, but that's fine. Y prime, what is y prime equal to? It's equal to x squared over y squared, right? Y prime is equal to x squared over y squared. Do you see that or not? Just put everything on one side and then cancel out the 3. That's what you get. Any questions on this algebra manipulation? Should be 5? Yes. But you haven't prime, right? It will be in terms of y prime. You may not be able to do it in front of, with respect to x only. If you do it with respect to x, then that's fine. Okay? Great. Y prime is equal to x squared over y squared. Now what do I have to do here? I have to differentiate again. So y double prime. What rule should I be using here? I have a quotient of two functions of, everybody, x squared is a function of x, and y squared is a function of x, right? I have a quotient of two functions of x. How should I be doing this? So, what rule should I be using? Quotient rule. Derivative of x squared, what is that with respect to x? 2x times y squared, right? Minus the derivative of y squared with respect to x. Everybody, or preferably someone who hasn't spoken today. What's the derivative of y squared with respect to x? Please raise your hands. Please raise your hands. Yeah. 2y prime minus 2y prime times x squared over 1 to the 4. Are we good here? Any questions? Yes?
Do you have to solve it in between, or would it be possible to take the second derivative, like, from the function, like, initially? Like,
Oh, you meant solving from here. You mean solve for y in terms of x. Is that what you meant? Oh, okay, yeah. So here, yeah, you can do that. So this is x cubed plus 7 is equal to y, and then y is equal to minus 7, sorry. Yeah, that's fine.
meant, like, do you have to, like, solve the 3x squared plus 3y squared y prime?
No, you can differentiate from here as well.
Yeah.
Right? You can do that. You'll obtain the same thing.
Okay, confused.
Yeah. Okay, yeah. Is that what you meant, solving for y?
Yeah.
Yeah, so if you can solve it from here, but I guess that's why the example is easy here, right? The numbers are easy. If you solve it, you'll obtain the same thing.
I tried to do that, and I got y prime squared in the expression, so I think I did something wrong.
Where? Here?
Yeah.
No, you may get y prime squared because you have 2y prime times y prime. That's good. You have 2y, y prime. Yeah. So
And
that's
how
fine.
would that be equivalent to the thing that you got?
Just do an algebra and it will be. Okay? Great. Let's do one more where it's not possible to solve. Here you can do something else as your friend noticed. Thank you very much. By noting that this is the cube root of x cubed minus 7. What is y prime here? Y prime is 1/3 times x cubed minus 7 to the minus 2/3 times 3x squared. So y prime is equal to x squared times x squared minus 7 to the minus 2/3. And y double prime, you can use the product rule to get this done. This may be easier, right? Yeah, so y double prime, use product rule to get this done. So what do you get? You get 2x, x squared minus 7 to the minus 2/3 plus x squared, this is x cubed here, sorry, x cubed, plus 3x squared times minus 2/3, oh man, oh, sorry about that, x cubed minus 7 to the minus 5/3. Is that what you got? Okay. Thank you. Let's do one more with second derivative. Find y double prime at the point where x is equal to what? X squared plus xy plus y. And then you move on. At the point where you find y double prime of 1, where okay, using implicit differentiation. Let me just double check something. So if x is equal to y, yeah, okay, that's if x is equal to 1, so you have y plus y cubed is equal to 1. Yeah, fine. Using implicit. In here. Okay, great. Now, what do I have to do here? I have to differentiate y twice. what do I need to do? At the beginning, I need to find the derivative of y. First of all, I have a value of x. I have one value of x. What do I need to find? The corresponding value of y. And we hope that there is only one. From the formulation of the question, there's only one. Okay? So if you find that you have multiple values of y, then you have something wrong. Okay? Great. If x is equal to 1, what can I say about y? So this is just 1 plus y cubed is equal to 1. So it's y plus y cubed is equal to 0. Let me factor out a y. Now, a product of two factors is 0 if and only if one of these two factors is 0. Right? Can y squared plus 1 be equal to 0? Can y squared plus 1 be equal to 0? So can y squared equal minus 1? Everybody, can a square be equal to minus 1? No, unless you have seen complex numbers, but on the real line, since 1 plus y squared is always positive, then y is equal to 0. So if x is equal to 1, and y is equal to 0. Now, let's differentiate to find the value of y prime, or let's differentiate to find y prime. So d by dx of x squared plus, is it plus xy? Yeah, plus xy plus y cubed is equal to d by dx of 1. Great, let me differentiate. Derivative of x squared, what is that equal to? It's 2x plus xy, let me differentiate xy, the product rule. Derivative of x is 1 times y, plus x times the derivative of y, which is y prime, plus the derivative of y cubed is 3y squared y prime, which is equal to 0. Let me factor this out, or let me factor a y prime out. So it's 2x plus y, plus y prime, times x plus 3y squared is equal to 0. What is y prime equal to? What is y prime equal to? Y prime is equal to minus 2x plus y, so it's minus 2x minus y over x plus 3y squared. Okay, that's very nice. I need y double prime. In order to obtain y double prime, I have to differentiate y prime again, right? So far so good, everybody? Great. Now, what is the operation I'm having here? It's a quotient, right? It's a quotient of two functions of x. So I'll apply the quotient rule. What is y double prime? The derivative of the top. What's the derivative of the top? Derivative of 2x. The derivative of minus 2x is minus, yeah? So try to solve for this, right? Is this good? Put this one on the other side, right? And divide by x plus 3y squared. You see that? Okay. Is that good, everybody? Did people got this? Did people get this? Yeah? For those who are trying it on their own? Great. So what is y double prime? Let me differentiate this. Derivative of minus 2x is minus 2 times the derivative minus the derivative of y minus y prime times x plus 3y squared minus the derivative of the denominator. What is the derivative of the denominator? It's 1 plus 6y y prime times minus 2x minus y over x plus 3y squared. Squared, right? So far so good, everyone? Yeah, so far so good? Any questions? Great. What do I need here? I need to find the point, the value of y double prime when x is equal to 1. We need y double prime of 1. Okay, so what do we need? What are the things I need to plug in? We have x is equal to 1. We have x equal 1. And we also have y is equal to 0. Right? Because we found that if x is equal to 1, then y is equal to 0. What is really missing here? What is missing here? The value of y prime. Could I find the value of y prime? I can find it here. We can also find, we also need y prime. When x is equal to 1 and y is equal to 0. Luckily we can find that. What is y prime of 0? Y prime of 0, y prime at x equals 0, x equals 1, and y is equal to 0. What is that? You can plug that in. So you get minus 2, right? That's minus 2, right? Minus 2. And now you just substitute. Y double prime would be equal. Minus 2 minus y prime. Oh, whoa. So it's minus 2 minus minus 2, which is 0, right? You see that? Yeah. So you get y double prime is 0 times whatever that is, x plus 3y squared is. So it's 0 minus 1 plus 6 y prime, so 1 plus what is y equal to is 0, so right, that's very nice. Minus 1, minus 2x minus y, what's minus 2x minus y? X is 2, so it's minus 2, right? X is 1, so it's minus 2, right? Yeah, minus 2x is minus 2. And x plus 3y squared, so it's 1 squared. And I get y double prime is equal to 2. Is that good? Great. Okay. We have 2 minutes left. And we will, 3 minutes. We will just give a small other thing using implicit differentiation. So we finish this section. And, okay, so maybe I want to talk about the midterms, the trig formulas you need to know. Okay, maybe it's, so the trig formulas you need to know for the midterm. What are the trig formulas you need to know? Sine squared plus cosine squared. What is that equal to? 1. Secant squared plus, tangent squared plus 1 is equal to, have you seen this formula before or not? How do you get this from here? You just divide by cosine squared, right? Divide both sides by cosine squared, that's what you get. What do you have as well? Cotangent squared theta plus 1. Now if you divide by sine squared is equal to cosecant squared theta. I think that's it. If there's any other updates, I'll let you know. And then, no, not that's it, but you have 2 more, right? It's cos 2 theta, the double angle formula. I mean, if you know the double angle formula, you have to know the half angle formulas as well, right? They're equivalent, no? Yeah? Cos 2 theta is what? It's 2 cos squared theta minus 1, which is also equal to 1 minus 2 sine squared theta, which is also equal to cos squared theta minus sine squared theta. And you have sine 2 theta is equal to 2 sine theta cos A. Okay, now from these you can derive the half angle formulas. I think that's what you call them, the half angle formulas. This is cos 2 theta also. From this one, what do you get? You get that cos squared theta is 1 plus cosine 2 theta over 2, right? And from this one, you get that sine squared theta is 1 minus cosine 2 theta over 2. Okay, and the half angle formula, right, those are, so okay, those are the, in a small application, for example, if you have a multiple choice, and I tell you to find if y is equal to tangent theta or tangent x minus x, okay? And I can tell you find dy by dx. An option could be, so what is dy by dx? What's the root of tangent? Secant squared minus 1. Look at the trig formula. Secant squared minus 1 is equal to what? Tan squared. Okay, so that could be something like that. Okay? Great. So these are the trig formulas you need to know. If there is anything else, I'll let you know Friday. Okay, great. See you all Friday.